Hello everyone. Today's topic is electric current. For understanding this topic, we should first understand the concept of charge. I am taking a glass rod and piece of silk cloth. I am going to rub this glass rod with the silk. So electrons will transfer from glass rod to silk, and as silk gains electrons, it becomes negatively charged, and as glass rod loses electrons, it becomes positively charged. So there are two types of charges, positive charge and negative charge. Now let us understand the mechanism of this positive and negative charges. Like charges repel each other. These are neutral, and unlike charges will attract each other. Now, I am taking a new glass rod and a new piece of silk, connect them with a wire. If I connect small bulb in between, what will be your observation? Will the bulb glow? Answer is no. Why is it not glowing? Because there are no charges accumulated on glass rod and silk. They are neutral. Now, I am taking same glass rod and silk and rubbing this glass rod with silk. Glass rod gains positive charge and silk gains negative charge. Now I am connecting them with wire. Now negative charges, that is electrons, are flowing from one point to other. So when charges flows from one point to other, it constitutes current. Charge is symbolically denoted by small q or capital Q. Now for measuring charge, SI unit is coulomb. It is denoted by capital C. Now coulomb is quite a bigger unit of measuring charge. So for measuring smaller magnitudes of charge, we use prefix milli. So 1 millicoulomb is equal to how many coulomb? Prefix milli has its magnitude 10 raised to minus 3. So 1 millicoulomb is equal to 10 raised to minus 3 coulomb. Next is 1 microcoulomb. It is equal to how many coulomb? Micro prefix has magnitude 10 raised to minus 6. So it is equal to 10 raised to minus 6 coulomb. And last is 1 nanocoulomb. It is equal to how many coulomb? Nano has its magnitude 10 raised to minus 9. So 1 nanocoulomb is equal to 10 raised to minus 9 coulomb. Next part to be understood is charges may be positive, may be negative, right? Now, there may be positively charged object, there may be negatively charged object. In case of positively charged object, it will have deficiency of electrons. Then and then only it is having positive charge. And in case of negatively charged object, it will have excess of electrons. So, how to determine amount of charge on positively charged object and negatively charged object? Then the method is by determining the number of electrons in deficit, and here how many excess electrons are there. That will help you getting the charge of this object. Amount of charge formula is number of electrons multiplied by the charge of one electron. Amount of charge on positively and negatively charged object can be determined by this equation. Here, how many electrons are there in deficit? That is your N. And in negatively charged object case, how many electrons are excess? That is going to be your N, right? And number of electrons multiplied by charge of one electron will give you total charge. Now, I want to find out how many number of electrons are there in 1 coulomb charge. Then we will proceed in this way. 1.6 into 10 raised to minus 19 coulomb is the charge of 1 electron. Then 1 coulomb carries how many electrons? So, number of electrons in 1 coulomb charge, it is equal to, you have to cross multiply it. So 1 divided by 1.6 into 10 raised to minus 19. So if you will calculate, you will be getting answer 6.25 into 10 raised to 18. So number of electrons in 1 coulomb charge will be equal to 6.25 into 10 raised to 18 electrons. There are two types of materials, non-conductors and conductors. Non-conductors also called as insulators. In case of non-conductors, charges are always in a static condition. But in case of conductors, there are so many free electrons. So if we apply proper potential difference, this free electrons can flow, or we can say charges can flow, right? and this flow of charges constitutes electric current. So, flow of current is nothing but flow of electrons in the wire. Now, we will start with topic electric current. It is symbolically represented by capital I. I am taking a wire. I am going to cut this wire perpendicular to its length. This is the length of the wire and I am cutting it perpendicular to the length. Then the circular surface which I got after cutting, it is called as area of cross section of the wire. And how much charge is flowing through this cross section? In time 1 second is equal to the current flowing through this wire. So we obtained the formula current is equal to charge upon time. And in definition it is written as rate of flow of charge is called as electric current. We got the formula. Now we are going to derive the units. Charge is measured in coulomb, division sign. Time is measured in second. So unit of current is coulomb per second. But Sir Andre Ampere was the scientist who did lot of inventions in this term. In honor of that scientist, unit of current is given as ampere and symbolically it is denoted as capital A. Looking at this, it is very clear. 1 ampere, it is equal to 1 coulomb upon 1 second. Now let's define the unit 1 ampere. When 1 coulomb charge flows through the cross section of the wire in time 1 second, then current flowing through the wire is equal to 1 ampere. So definition is current is defined as the rate of flow of charge. That is how much charge is flowing in 1 second. And 1 ampere definition is 1 ampere is the current which flows when 1 coulomb of charge passes through it in 1 second. Passes through cross section of that conductor in 1 second. We studied electric current formula in terms of charge as charge upon time. But charge is equal to number of electrons multiplied by charge of 1 electron. Division sign and time as it is. So we got our new formula. Current is equal to NE by T. Now let's talk about the direction of current. Electrons will definitely flow from negatively charged terminal to positively charged terminal. When we talk about electric current, we are dealing only with conventional current. So symbolically, the conventional current is said to flow from positive to negative. What is conventional current? In our day-to-day life, we might have observed always energy flows from higher potential to lower potential. So in this case also we are going to consider the flow of current from higher potential to lower potential. So we are considering conventional current flowing from positive terminal to negative terminal. So when we talk about electric current, we are dealing only with conventional current and not the electrons flow. Now, measurement. Already we have understood the formula for calculating current, but there is one direct device also which can help us measuring current. Name is ammeter. Important note is ammeter has to be connected in series with the appliance through which you want to measure the amount of current. Current is a scalar quantity. We are saying it flows from positive to negative. Then how come it is a scalar quantity? Always flows in one direction only. It is a unidirectional quantity. So it is a scalar quantity. Through formula, charge is scalar, division sign, time is also scalar. Ratio of two scalar quantities gives you a scalar quantity. So from formula also we can say that current is a scalar quantity. Current flows through metals, conductors and fluids, that is electrolytes and gases also. In case of metals, there are so many free electrons. So movement of this free electrons constitutes the current in that conductor. Now, what are free electrons? The electrons in the outermost orbit are called as free electrons. While in case of electrolytes and ionized gases, there are positively charged ions and negatively charged ions called as cations and anions. Movement of these cations and anions constitutes current in the electrolytes and ionized gases. Now, these two formulas are helpful for conductors, but current flows through electrolytes also. Let us consider there are N1 number of cations and N2 number of anions. Charge of one cation is Q1 and charge of one anion is Q2. I is equal to N1 Q1 plus N2 Q2 divided by time. Thank you.